Okay, guys, how's it going today? Today we're going to continue with logs, of course. And today this is actually a fun lesson, believe it or not. A lot of people always stress out when they have an exponential or a logarithmic equation, but it's actually not that bad if you know the properties and you know how to manipulate logs and exponents. First of all, an exponential equation is any equation that contains the form b to the cx, such as a equals b to the cx, where the exponent includes a variable. So if I had, a equals b to the third, that's technically not an exponential because I don't have an exponent I don't have a variable in the exponent. If I went 3x, then I'm talking about an exponential. I need a variable in the exponent, basically in a nutshell, to have an exponential equation. And you can use logs, of course, because remember logs are the inverse of exponents and exponents are the inverse of logs. So you can use logs to solve exponential equations. And you can use exponents to solve logarithmic equations, okay? I'm going to have a couple little samples here. There's two different types of exponential equations, and then we'll do the logarithmic equations. As far as the exponential equations goes, gentlemen, the first type that we work with is when you have a common base, okay? When you have a common base, and this, it's not difficult, but you do have to really understand what you're doing. You have to know your multiplication tables very, 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 very well. For example, I have 16 raised to the 3x power equals 8. All right? I don't know what to do here. There's nothing I can do here except change the bases. Isn't 16 here, guys, isn't that 2 to the 4th power? Okay, and that's to the 3x, right? Because 16 is 2 to the 4th, and 2 to the 4th is being raised to the 3x. You with me, guys? And then 8 is 2 cubed, right? So that's going to go ahead and turn into 2 to the 12x. How did I do that? Because when I raise a power to a power, I multiply the powers, and I keep the base, and that equals 2 cubed. Now, here's a law that, I don't know if it's a law, but this is what happens. If two numbers with the same base are equal, then their exponents are equal, okay? So if two numbers with the same base are equal, then their exponents are equal. So since the base of 2 and the base of 2, those are equal, literally, they go away, and I have 12x equals 3. Now, why do they go away? Because I basically took the log of both sides, in essence. Okay, but what you want to remember is whenever you have the same base, you have two bases that are equal, their exponents are going to be equal. So now you divide by 12, by 12, and x will equal 1/4. It's that simple, gentlemen, like I promise. If you know the bases. For example, let's look at number 2 here, gentlemen. 27 and 81, what base do you think they have that it's in common? 3, very good. 27 is 3 cubed raised to the 3x power, and 81 is 3 to the 4th. So I'm going to have 3 to the 9x because, again, the powers property of exponents. And that's going to equal 3 to the 4th. When I have equal bases equaling each other, those guys go bye-bye, and I have 9x equals 4, so x equals 4/9. Thank you very much, sir. It's that simple. Not too bad, right? Not too bad. Let me just want to see something really quickly. See if there was another one that I should give you. No, okay, now we're going to go to different bases. Okay, so now, when the bases are not the same, my friends, solve the equation by simply taking the logarithm of each side of the equation. If the m and the n are positive and m equals n, then the log base m will equal the log base n. That's all fancy talk. Basically, let me show you how this works. Do I have a common base here between 15 and 285? No. 5 times 3 is 15, but 5 to some power is never going to be 15, sir. And also, some people think, oh, 15 itself. 15 squared is 225. So there were no common bases that I can raise to a power for 15 and 285. However, I can take the log of both sides. When I take the log of both sides, remember, whatever I do to one side, I do to the other. When I apply the log to both of these sides, my friends, doesn't this 3x go to the front? Because whenever I have a power, isn't that represented when I write it in log format as a multiplication? So I'm going to have 3x log of 15 equals log of 285. And now, guys, very similar to the change of base. Very similar. You're going to love this right now. Don't think this over too hard. What would I do, in your opinion, to solve for x? What is the relationship between 3x and the log of 15? They're being multiplied, right? So yes, you would divide by 3 log of 15. 3 log of 15. That's exactly what you can do. Now, in your calculators, it depends if you purchase the calculator that I told you to purchase or not. Some calculators you have to work backwards here, guys. Some calculators you can just work straight forwards, okay? If you just go straight forward and you have a straightforward calculator, literally you're going to put in log 285 divided by 3 times log of 15. And what does that give me? Guys, you do have calculators, right? Log 285 divided by 3 times the log of 15. What does that give me? Okay. Okay. Little confusion with the calculators here. Okay, if you guys got the TI 30, like I had told you, you're going to show, it should show like this in your window. You're going to hit log, and a parenthesis will show up when you go 285. You're going to go divided by parentheses 3 log, another parenthesis will come up, 15, and then you close the parentheses. You do that, and it's going to be 0.6958 roughly. Okay? Now listen, if you have a calculator that goes backwards, okay, it's a little bit different. If you have a calculator that goes backwards, which again I do not like, but you got to go 285, you would put in 285 log, okay, 285 log, you'll get an answer. Then you'll go divided by 15 log times 3. Okay, very, very weird. I don't like that. That's why I please want you to get the correct calculator. Get a calculator that goes forwards, not backwards, please. Okay? But the answer is 0.6958. Next, 5 raised to the 2x equals 130. Do I have a common base here? No, unfortunately not. But I can log both sides. So I'm going to have 2x log of 5 equals log of 130. Divide both sides by 2 log of 5. 2 log of 5. And x is going to equal, remember in your calculators, log of 130 divided by parentheses 2 log of 5. And what'd you guys get? 1.5122. That's exactly correct. Good job. Does that make sense, everybody? Promise? Pablo, you got it? Thank you, my brothers. You guys got this? Okay. Let's move on. Okay. Now a logarithmic equation, guys. All right, now we're going to do the log equations. A logarithmic equation is an equation that includes one or more logarithm involving a variable. So I want you to solve each logarithmic equation here. When we're solving logarithmic equations, it's, I think, easier, in my opinion. If I were to tell you to graph this, guys, wouldn't we have to turn this into an exponential? Because that's how we can start finding values, correct? Same exact concept here. Let's go ahead and turn this from a log equation into an exponential. So what is the base of log when there's nothing there? Okay, so pay attention, my brothers. It's going to be 10 squared equals 4x minus 3, literally. So this is going to be 100 equals 4x minus 3. You add 3 to both sides. 103 equals 4x divided by 4. So x would equal 25.75. In my opinion, I think that's even easier. And I really like the exponential ones because all you got to do is log both sides if you have to, or change the base. That's it. That's x. That's what x equals, sir. You literally went from a logarithmic equation to an exponential. Literally. Okay? May I continue? Yes? Okay. Give me 1 second. Okay. All right, so let's continue. Number 2. I got log of 3 minus 2x equals negative 1. So, what's the base of this log here? 10, yeah. So I'm going to go 10, excuse me, to the negative 1 equals 3 minus 2x. So, this turns into 1/10 equals 3 minus 2x. I'm going to subtract 3 to both sides. Common denominator is 10. That becomes a negative 30. So I have negative 29/10 equals negative 2x. Get rid of that negative 2x by multiplying by the reciprocal to both sides. So this is going to be 29/20 equals x, which is 1.45. So again, 10 to the negative 1 equals 3 minus 2x. 10 to the negative 1 is 1/10. I subtracted 3 to both sides, found a common denominator. That gave me negative 29/10. Okay? And then I had negative 29/10 equals negative 2x. I get rid of this negative 2x here by multiplying by the reciprocal. When I multiply by the reciprocal of negative 1/2, I'm going to get positive 29/20, which is 1.45. Does it make sense? Okay. For number 3, okay, we're complicating it just a little bit, okay? Just a little bit. For number 3, how can I write this as one single logarithm? Hint, hint. Right. So this is going to be log of x times x minus 3 equals 1. Does that make sense, my brothers? Again, I'm not trying to be a broken record, but what is the base of log when there's nothing there? 10. Thank you, my brothers. So I have 10 to the first power equals x times x minus 3. So now we're just going to do some simple algebra, okay? We've got 10 equals x squared minus 3x. Subtract 10 to both sides. X squared minus 3x minus 10 equals 0. What times what is negative 10, but when I add together is negative 3? Negative 5 and positive 2. Thank you. So x will equal 5 and or negative 2. Does that make sense? Yes, sir. If you have a base and it's not 2, then you're going to do the change of base. you're going to do the change of base formula. So for example, if I had like log base 2 of x equals whatever. Well, no. I mean, no. You don't have to do anything here. If it's a different base, how do you solve this? 2 to the 9th equals x. Thank you, Papo. Thank you. Thank you very much. Thank you very much. Okay, number 4 is a typo. I apologize. That should be log 6. Please go ahead and correct that. That was my mistake. I do apologize. No excuses. That was my mistake. Okay, but now that I have log 6 minus log 3x equals negative 2, how can I write this as a single logarithmic function? It's division, right? So I'm going to have log 6 divided by 3x equals negative 2. What's the base of log? 10. Thank you. So I have 10 to the negative 2 equals 6 over 3x. No, don't reduce it. Well, you can reduce it, yes. If you want, let's reduce it. Let's go ahead and do it the right way. This is going to be 1 over 100 equals 2 over x, right? Cross multiply, x equals 200. Or you could have just said 1 over 100 equals 6 over 3x. Cross multiply, 3x equals 600. Divided by 3, x equals 200. Sir, thank you. What's up? Oh, I thought you had a question. I'm sorry, my brother. Does that make sense, guys? Does that make sense? Okay, I got a few more minutes, so let me just give you some extra practice problems, if you don't mind. Is that cool? All right. How about this, guys? What if I said solve 7 to the 4x equals 800. I'm going to give you a couple seconds to do this on your own. I'm going to pause the video. Let's see what you got. All right, guys, what do you got? Yes, I got 0.8588. Some of you guys rounded it to 0.86. That's fine. Let's go over it really quickly. The first statement or comment was, Mr. Moore, there's no log. Exactly. You're going to have to log both sides in this case. Now, wait, let's go back. Why are we logging? Thank you, sir. There's no common base. Excellent. If there's a common base, easy. You go ahead and change you make the bases equal and you change the exponents and you're done. But if there's no common base, just log it. Log both sides. Excellent job, son. Excellent. So I'm going to have 4x log 7 equals, equals log of 800 divided by 4 log 7 divided by 4 log of 7. Remember, in your calculator, log of 800 divided by parentheses, 4 times log of 7. If you're doing backwards calculator, it's 800 log divided by parentheses 7 log times 4, close parentheses. Either way, you get the 0.8588. Does that make sense, guys? You promise? All right, what about if I give you, let's see. How about if I give you one of these here? What if I give you, okay, this is a good one. Let's go 5 to the 3x equals 1 over 25. 1 over 125. Okay? Now, just so you know, you can use the log even if you have a common base. You can. You could do the log method. You could log both of these sides, and you're going to get the right answer still. I'll prove that to you now in a second. But for those of us who are really starting to understand this, do I have a common base? 5, yeah. This is 5 to the 3x equals 5 to the negative 3, right? Yes, sir. Let me do that when I get to it, please. Give me 1 second. Right now I want to focus on this. Yes, sir. Well, some people don't see that, sir. Some people don't see it, so no. The thing that I was asked, don't you just see that it's negative 1? Some people don't see that, so change the base. The bases go bye-bye, and yes, you're absolutely right, though, my brother. X does equal negative 1. Now, let's say you just didn't see that. You could log both sides. Log both sides. And this is going to be 3x log of 5 equals log of 1 over 125. So you divide by 3 log of 5. Divide by 3 log of 5. Let's see if this works. When you guys plugged it in, do I get negative 1? So that's the beauty. If you know how to do the change of base, yes, it's going to be a lot quicker. But in a nutshell, in a pinch, if you don't see the base, so what? Do it the log method. Does that make sense, boys? Thank you very much. May God bless you. Have a wonderful day. Thank you for a good lesson. You're welcome. Welcome.